All right, ladies and gentlemen, today we're going to talk about quadratic roots. Now remember back at the beginning of this section, I said to you the reason we factored was to find the roots, and I had you write that down. Well, here is why we are doing this, is we are finding the roots. What are roots? Well, the roots are points at which the parabola intersects the x-axis. Now what makes this a little tricky is that there are three other names besides roots that it could be called. One of the other names would be zeros. Another name is solutions. Another name is x-intercept. So solutions, if I said to you, solutions, find the solutions for me, you're going to be looking for the points at which the parabola intersects the x-axis. If I said, hey, give me some zeros for that parabola, you would have to tell me that the points at which the parabola intersects the x-axis. Or if I said, hey, what are the x-intercepts of that parabola? Again, you're looking for the points at which the parabola intersects the x-axis, or the roots. Now, look at this parabola. It's a downward parabola. It is crossing the x-axis in two places. It is crossing the x-axis in two places. So that means there are two solutions. It doesn't matter if it's a downward parabola or an upward parabola. There are still two solutions. Okay, because it's still crossing the x-axis in two places. It doesn't matter where it's located on the graph, at the right or to the left. If it's crossing through the x-axis in two places, then there are two solutions. But what if it's up here, up in the air, kind of in the first quadrant, or up in the air in the second quadrant? Okay? It doesn't matter. But now, look, there are no places that it's touching the x-axis. So that means that there are no roots. None. Zero. But don't use the word zero. Say no roots. Okay? Now, what if I'm down here in quadrant 3 or in quadrant 4? Well, in quadrant 3 or quadrant 4, it's never, ever, ever going to go through the x-axis because it's a downward parabola. And so it's just going to keep getting smaller and smaller and smaller, lower and lower and lower. So again, there are no roots. What if my parabola is touching on one place, my vertex, and my vertex is touching the x-axis? Well, that means there is one solution. All right, one solution if it's touching, the vertex is on the x-axis. All right, this is a big hint. Make your graph as accurate as you possibly can. All right, the more points you have, the more accurate it's going to be. So let's graph. Remember, the first thing I have to do is find my axis of symmetry. So I'm going to use the equation for axis of symmetry. Okay, I'm naming A equal and B equal. And my equation for axis of symmetry, I like you to write it on the paper, please. The opposite of B over 2A equals X. So now, when I do X equals -4 times 2 times 1, which is 2, -4 divided by 2 is -2. So the axis of symmetry is at -2. When I plug in -2 into my original equation, -2, the whole thing is quantity squared, which is going to be +4, plus 4 times -2, which is going to be -8 minus 5. And when all is said and done, and I follow the order of operations, I get -2, -9 for my vertex. So there's my axis of symmetry at -2. My vertex is at -2, -9. Now notice it's an upward parabola. It has a long way to go before it hits the x-axis. So let's make some points. All right, so now I like to use 0. Please write down 0 as one of the points you're using for x. And remember, we talked about this in the last video, that anytime I use 0 for x, my y-intercept is going to be the constant. And in this case, the constant is -5. So my y-intercept is at 0, -5. All right. Oh, that didn't quite get me there, did it? I remember I want to see where this parabola goes through the x-axis. All right, let's do another problem. Oh, wait a minute. So I'm looking at this, and I just remembered that that's the axis of symmetry. So if I folded that axis in half, my point that I had here, 0, -5, is going to land on the other side of the axis of symmetry, the same distance away, 2 spaces away from the axis of symmetry. Well, 2 spaces to the right of the axis of symmetry gives me the point I just found, 0, 5. 2 places to the left of the axis of symmetry lands at what, -4, -5? So that's a point I can add to my table of values if I'm making a table of values. All right. So I'm going to use 1 now. 1 squared is 1. Plus 4 times 1 is 4 minus 5. Well, 1 plus 4 is 5 minus 5 is 0. Oh, I found one of my zeros, but I can see that it's going to go through, the parabola is going to go through the x-axis in one more place. So if I folded my line in half, where would that point 1, 0 land on the other side of the axis of symmetry? Well, it's 3 spaces to the right, so I'm going to go 3 spaces to the left, and 1, 2, 3, and I get this point. Did everybody get the same point that I did? Did you get that it was 1, 2, 3, 4, 5, -5, 0? Okay, there's my parabola. So now I have to write my roots because that's what the directions are asking me to do. When I write the roots, I don't write them as an ordered pair. I write them in set notation or with set brackets, okay? I have to put x equal because those are the roots. X equal, and then I'm going to write set brackets 1 and -5, or -5 and 1. Okay? So here's what I want you to do. This is an equation of a line, and I've given you the points that I want you to graph. And I've also told you which one of those points is the vertex. So pause the video, graph the points, and then come back and start the video again. All right, so I've now graphed the points. All right, so using the axis of symmetry, I could graph the other points, but what do you notice? Where did that vertex land? The vertex landed on the x-axis. That means that the x-axis is the vertex, and it means that there's only one point. So my answer, my roots, my solutions, my zeros, or my x-intercepts is 1, 0. So x is equal to 1. Okay, so the root, there's only one root, is x equal 1. All right, before we go on, I want you to do number 3 on this page, and I want to see your work for it, and I want you to graph it, and then come start the video again. We have one final thing to go over. What is the discriminant? All right, welcome back. So, what is a discriminant? Isn't that a cool word, discriminant? We can use the discriminant to predetermine the number of solutions that there's going to be. All right, so if you are just asked to tell how many solutions, and you will be asked that on a test at some point, how many solutions to this quadratic, you can say, oh, I can use the discriminant, and then you don't have to do all of the work of graphing. All right, this is the discriminant. D for discriminant, equals b squared minus 4 times a times c. Write that down. D equals b squared minus 4 times a times c. All right. So now, if D, the discriminant, is greater than 0, there are going to be 2 solutions. If D is exactly 0, then there is 1 solution. And if D, the discriminant, is less than 0, you're going to know that there are no solutions. All right, so notice that I need all 3 A, B, and C defined here. So A is 1, B is 5, C is 4. So let's plug it into the formula for discriminant. D equals 5 squared B squared minus 4 times AC, which is 1 times 4. So using the order of operations, 5 squared is 25. 4 times 4 is 16 times 1 is still 16. 25 minus 16 is 9. Okay, so D is equal to 9. Now those 3 dots in triangle means therefore there are 2 solutions because D is greater than 9. Let's do one more. All right, so I've done the work here for this last one. Y is equal to x squared minus 3x plus 10. First thing I did was I said A equal, B equal, C equal. And then I plugged it in. D equals negative 3 squared minus 4 times 1 times 10. All right, using the order of operations, D is going to be equal to negative 31. Therefore, there are no roots, 0 roots. There aren't any. If you see this little symbol over here, that means that there are no roots. It's called the null symbol. No roots, okay? Or there's the answer, there is no answer. All right. All right. That's all for today, and we'll see you tomorrow.